Hey, welcome. Today we're going to pull back the curtain on the secret journey your data takes every time you use an app. It's all about something called API security, and trust me, you rely on this hundreds of times a day and probably don't even know it. So, think about it. You tap a button on your phone, maybe to log in, post a photo, or check the weather, and it just happens. It feels totally instant, right? But behind that one little tap, a message with your request is being sent on a super high-speed, high-stakes journey across the internet. And securing that journey, well, that is absolutely everything. And at the very heart of this journey is the API, which stands for Application Programming Interface. The easiest way to think of it is as a digital messenger. It's like a dedicated courier that grabs your request, delivers it to exactly the right server, and then hustles back with precisely what you asked for. So today, let's follow that messenger and see all the ways we keep it safe. And this fantastic illustration right here is going to be our map. It basically lays out the entire security obstacle course that our little digital messenger has to run. We're going to follow the path of just one request, from the second it leaves your phone to the moment it's tucked away safely on a server.
All right, let's start at the very beginning. Before our messenger can even dream of getting close to the main server, it has to get past the guards at the front door. This is the first and maybe most important line of defense.
Every single request, without exception, has to face this initial three-step check. It's got to show up at the gateway, make sure it's at the right address, and prove it's not part of some huge mob trying to crash the gates all at once. First up is the API gateway. And honestly, the best way to picture this is to think of it as the bouncer at the front door of an exclusive club. Seriously, its entire job is to stand there, direct all the traffic, and check every single request to make sure it looks legitimate before it's allowed to go any further. It is the one and only point of entry. Okay, next, our request needs to be absolutely sure it's talking to the right service. That's where versioning comes in. You've probably seen this before, like a V1 or V2 in the web address. It's kind of like making sure your mail gets delivered to the new, renovated building, not the old one that's about to be demolished. It's what stops your app from breaking every time the server gets an update. And finally, right before it can get inside, our messenger gets checked for rate limiting. Now, this is a really simple but incredibly powerful rule. You just can't send 1,000 requests every second. It's a system that guarantees everyone gets fair access, and, crucially, it's a frontline defense against those nasty denial of service attacks, where someone tries to flood the server with junk traffic. Okay, so our request made it past the front gate, awesome, but it's not home free just yet. Now comes the digital ID check. The system needs to know two fundamental things. Who exactly is this messenger, and what is it allowed to do here? And this brings us to a super important distinction: authentication versus authorization. Think of it like this. Authentication is proving who you are. That's like showing your driver's license to the bouncer. Authorization is what you're allowed to do once you're inside. That's like the bouncer checking the list to see if you have access to the VIP lounge or if you can only be on the main floor.
So how does an application actually prove who it is? Well, a lot of the time, it's with secure API keys. These are just long, unique strings of text that act like a secret password. The app includes this key with its request, and the server checks it to make sure the request is coming from a trusted, legitimate source. So our messenger is cleared, its identity is verified, we're making progress. But what about the actual package it's carrying? The data itself needs some serious protection, both while it's in transit and after it arrives. This is where HTTPS comes into play. If our data is a valuable package, then you can think of HTTPS as the armored truck it travels in. It encrypts the entire connection, creating a totally secure private tunnel between your app and the server. So if anyone tries to eavesdrop on the connection, all they'd see is scrambled, unreadable garbage. So once the armored truck arrives safely, the package has to go through customs. This is what we call input validation. The server meticulously inspects the contents of the request, checking for any bit of malicious code or weird data that could be used to attack the system from the inside. It's just like a customs agent checking luggage for anything dangerous. And finally, after the message is delivered and validated, the data gets locked up in a vault. We call this encryption at rest. The information is scrambled while it's being stored in the database. What that means is, even if a thief somehow managed to physically steal the hard drives, the data on them would be completely unreadable and totally useless without the secret encryption keys. So far, we've really only talked about the defenses our messenger faces on its active journey. But great security isn't just about gates and checkpoints. It's also about having an always-on security team that's working tirelessly in the background, monitoring and maintaining the entire system around the clock. Now, this team is basically always focused on three core missions: proactively looking for weak spots, keeping all the system's building blocks secure and up to date, and of course, watching over everything like a hawk.
Let's break that down real quick. Logging and monitoring is like having security cameras everywhere, recording everything that happens. If something weird goes down, the team can just review the footage to see what happened. Dependency management is all about making sure all the third-party software that the application is built on is updated with the latest security patches. And security audits? That's like hiring a team of good guy hackers to try and break in, so you can find and fix holes in your security before the bad guys do. So, after following our data on this whole journey, what's the big takeaway? Well, it's that good API security isn't just one single thing. It's not a single lock on a single door. Nope. It's a really sophisticated, multi-layered system. Every single step we just covered, from the gateway and the ID check to the encryption and the background monitoring, each one is another crucial protective layer. And this really illustrates the challenge we're all facing, doesn't it? Every app, every smart device, every single online service we use relies on these digital messengers. As they get more and more tangled up in our daily lives, the big question isn't just how do we secure one API, it's how do we secure this massive global ecosystem that's built on trust, data, and these countless invisible journeys happening every single second of every day.